Welcome to my channel Math Psych. Here we can nurture our ethic values and mathematics.
Continuous curves. A curve without any breaking points or jump is called continuous curves. Theoretically, how do you prove a curve is continuous? Some people use graphing calculator to find whether the curve is continuous at a point or not. But here we are going to find out with the paper and pen how do we prove the curve is continuous. Let us suppose there's a curve y equal to f of x and we're going to check the continuity at x equal to a. Okay, let us check first whether limit extends to a exists or not. How do we find it? Approaching it from some left hand side or the right hand side. For example, if you are approaching x equal to 2 from the left hand side, you are going like 1.97, 1.98, 1.99, 1.999, 1.9999, then 2. On the other side, it will be like 2.01, 2.009, 2.01, 2.000001, then 2. So this is what the left hand limit, the right hand limit. But theoretically, you don't need to worry like you need to substitute so many points like that. Just say limit extends to a minus and limit extends to a plus. We are going to study that later. If LHL and RHL are equal, then you can call limit extends to a exist. Otherwise, limit does not exist at that particular point. How do you find left hand limit and the right hand limit? For the left hand limit, put x as a minus h and put h tends to 0. And for right hand limit, replace x as a plus h and put h tends to 0. In both the way, as h is tending to 0, x is tending to a itself. But a minus h mean we are approaching it from the left, a plus h mean we are approaching it from the right. Anyway, x is tending to a itself. Let us see an example. Here is a function with split forms like f of x is 3x minus 2 when x is lesser than 3 and x squared plus 1 when x is greater than or equal to 3. Okay, let's find the existence of limit at x equal to 3. Limit extends to 3 minus, approaching it from the left hand side. You just have to replace x as 3 minus h. So what we are going to find is limit h tends to 0 f of 3 minus h. Okay, when you have to find what is f of 3 minus h, you have to substitute in 3x minus 2 because this is where x is lesser than 3. 3 minus h is obviously lesser than 3, so we have to substitute 3 minus h in 3x minus 2. So this is going to be like 3 times of 3 minus h minus 2. And simplifying and putting h as 0, we get 7. And on the right side, right hand limit extends to 3 plus f of x. That means we have to replace x as 3 plus h. And we are getting limit extends to 3 plus f of x as limit h tends to 0 f of 3 plus h. But f of 3 plus h, that means we have to substitute f of x when x is greater than 3, that is x squared plus 1. So that will be like f of 3 plus h will be 3 plus h the whole square plus 1. Okay, and expanding 3 plus h the whole square, we get something. Then now we put h tends to 0, we get 9 plus 1, 10. So LHL is not equal to RHL. Then we can conclude limit extends to 3 f of x does not exist. Okay, suppose limit extends to a minus LHL and limit extends to a plus RHL are equal. Then is that enough to say the function is continuous? No. We need to say limit extends to a minus and limit extends to a plus are exist. That means limit extends to a f of x exists. The limit is existed. Even if the limit is existed, that value is equal to exact value when x equal to a, that f of a. Then only we can say the function is continuous at x equal to. This is the definition for continuity. Limit extends to a f of x equal to f of a. Okay, now let's see an example. It's given f of x is 3 phases. 7x minus 2 when x is lesser than 2. 3 times of x plus 2 when x is equal to 2. And 3x square when x is greater than 2. Okay, LHL. Limit extends to 2 minus at x equal to 2. We are finding limit extends to 2 minus. Limit extends to 0 f of 2 minus h. That will be like limit h tends to 0, 7 times of 2 minus h minus 2. We are substituting x as 2 minus h in 7x minus 2 because this is where x is lesser than 2, so 2 minus h has to be put in that place. On simplifying, we get 12. Okay, now we go for the right hand limit. Limit x tends to 2 plus f of x, that is limit h tends to 0, f of 2 plus h. F of 2 plus h, that means we have to substitute that in x is greater than 2. So 3x square will be like 3 times of 2 plus h the whole square. On expanding, we get 12. Right, LHL equal to RHL then. That means limit x tends to 2, f of x exists, and that is equal to 12. Okay, now we shall see what is f of 2. X equal to 2, the function is 3 times of x plus 2. We just replace x is 2 there. 3 times of 2 plus 2 will give us 12 itself. Okay, now limit x tends to 2, f of x is equal to f of 2. Thus, we can conclude the function is continuous at x equal to 2.
Now let us see a few more examples in continuous functions. Okay, first one. Check the continuity at a particular point. Given f of x is 3x minus 7 when x is less than 5, 2 times of x minus 3 the whole square when x is equal to 5, and x plus 3 times of x minus 5 by x minus 5 when x is greater than 5. Okay, first we shall find LHL as we already discussed. Limit x tends to 5 minus f of x is limit h tends to 0, 5 minus h. Then we need to substitute 3x minus h, 5 minus h and 3x minus 7. So we got finally when we substitute h equal to 0, then we get 8. The same way, when you are finding RHL, it has to be substituted in x plus 3 times of sine of x minus 5 by x minus 5. Replace x for 5 plus h and substitute in that thing. You end up getting RHL as 5 plus h plus 3 times of sine h by h. Oh, sine h by h when h tends to 0 is 1. So 3 into 1 is 3, 3 plus 5, 8. Okay. Now RHL and LHL are same. So we can conclude limit x tends to 5 f of x exists and is equal to 8. Now we will need to check what is exact value when x equal to 5. F of 5 is 2 times of 5 minus 3 the whole square, which is equal to 2 into 2 square, that is 2 into 4, yeah, that's 8. So limit x tends to 0, f of x is equal to f of 5, therefore the function is continuous at x equal to 5. Here, the other type, the question is to find the point of discontinuity. So where and all the function is not continuous, we need to check the continuity. You don't need to check for each and every point. Wherever the suspectable point, that point to be checked. Here the given function is f of x is x cube minus 3 when x less than or equal to 2, x square plus 1 when x is greater than 2. So here the point which can be suspected is x equal to 2. So check the continuity at x equal to 2. LHL is limit x tends to 2 minus f of x. So f of 2 minus h to be found. In that x cube minus 3 we have to replace 2 minus h, you get f of that will be like 2 minus h the whole cube minus 3. When h is replaced to 0, we get 5. And RHL, we get 2 minus 0 the whole cube, 9. 2 cube is 8, 8 plus 1 is 9. So LHL is not equal to RHL. Thus we can conclude limit x tends to 2, f of x does not even exist. So the function is not at all continuous at x equal to 2, because the function is, the limit does not exist, the function is not at all continuous. So only the point of discontinuity is x equal to 2. And the next example, we shall see if the question is to find the continuity of the function. So we have to take cases for this particular sum. It's given f of x is 2x when x is less than 0, 0 when it's between 0 and 1, 4x when x is greater than 1. So that means it has to be split into 5 parts. One is x less than 0, then 0 between 0 and 1, then between greater than 1, then at exactly 0, and then at exactly 1. Okay, first of all, let us take the case 1. What is when x is less than 0? Let c be any real number that belongs to minus infinity comma 0. Here the function f of x equal to 2x. So when you find limit x tends to c f of x, you are going to get like 2c, and f of c is also 2c. So literally this is a polynomial function. So polynomial functions are continuous, but still we want to prove it continuous, that's why we are writing it. Suppose if it is like a lesser mark question, like a 2 mark or 3 mark question, so you can directly write f of x equal to 2x is continuous function because it's a polynomial function. Therefore f of x equal to 2x is continuous for all x belongs to minus infinity comma 0. Okay, and second case, what if the function is between 0 and 1, or x between 0 and 1, then f of x is 0, obviously limit 0, exact value is also 0, continuous. And case 3, if it is more than 1, for all x greater than 1, we'll have f of x equal to 4x. Again, it's a continuous function, but when you are finding limit extends to c, we get f of limit extends to c, f of x is 4c, and f of c is also 4c, thus the function is continuous. Thus we can prove one thing, that apart from those points 0 and 1, the function is continuous everywhere. Now we will check the continuity x equal to 0 and x equal to 1. For x equal to 0, we know how to find LHL and RHL. For finding LHL, we have to substitute in 2x and we get 0. For finding RHL, we need to put that in 0, 0 as 0 itself. So LHL equal to RHL, limit exists, and f of 0 is also 0. Thus, the function is continuous at x equal to 1. Now, for checking at x equal to 1, limit extends to 1 minus f of x is f of 1 minus h, that is 0. And when you are finding f of 1 plus h, you need to substitute in the 4x thing. So 4 times of 1 plus h, so that will be 4 itself. So LHL not equal to RHL, thus limit extends to 1, f of x does not exist. So f is not continuous. So we can conclude one thing, that the function is continuous everywhere for all real number except 1. Now we'll see one more example. When the function is continuous at a particular point, how do we find the unknown values involved in the function? For example, let us see this example. It's given f of x is k cos x by pi minus 2x when x is not equal to pi by 2, 3 when x equal to pi by 2. And it's given the function is continuous at x equal to pi by 2, find k. Okay. So LHL should be equal to RHL, that is equal to limit extends to pi by 2 f of x, that is equal to f of pi by 2, because the function is continuous, so we can conclude these things. Okay, so thus limit extends to pi by 2 f of x, limit extends to pi by 2 k cos x by pi minus 2x. So we don't have any formula for k cos x by pi minus 2x. Suppose if I substitute pi minus 2x as some other variable, it may end up getting something by k, maybe the limits tending to 0, then that will be easy for us to make. So I just assume pi minus 2x equal to 4t. Why 4t? Why can't it be t or something else? Okay, you can understand that later. We just substitute 4t, because substituting whatever you can substitute, no problem. I am just simply substituting 4t because I have foreseen something. If I substitute t, then it will be more fractions involved. That's why I substitute 4t here. Okay, now what will happen? When x is tending to pi by 2, t tends to 0. Well, so limit t tends to 0, k cos of pi by 2 minus 2t. Instead of x, you can write pi by 2 minus 2t divided by 4t. Pi by 2 minus 2t. Cos of pi by 2 minus 2t is sin 2t. Okay, now you can understand. I would have taken 2t also. Okay, just I thought 4t. Anyway, you know sin 2t by 2t when t tends to 0 is 1. So sin 2t by 2t is 1. So k by 2 into 1. This is limit value. And f of pi by 2 is 3. So when you make limit extends to pi by 2 f of x equal to 5 by 2, we end up getting k by 2 equal to 3. Thus k equal to 6. Thank you for watching. Please share the good thoughts including this video. Also like and subscribe. Thank you.